Welcome to today's topic on oxidation and reduction reactions. This is one of the 5 topics that are being covered under the unit Bioenergetics Unit 1. Myself Dr. Mausmi Shankaradala, working as an assistant professor in the Department of the Biochemistry, SJCWA, hereby gives a detailed description about oxidation and reduction reactions in our biological system. Learning outcomes will be redox reaction, standard redox potential, and the examples. When there is a gain of oxygen and a loss of electron in a chemical reaction, oxygen takes place. Conversely, reduction occurs in a reaction when the oxygen is lost and electrons are gained. To put it simply, reduction is the removal of oxygen from a reaction, whereas oxidation is the addition of oxygen. In a chemical reaction, oxidation and reduction happen at the same time. An electron is gained by one element and lost by another. These kind of reactions are known as redox reactions or oxidation-reduction process. Oxidation and reduction are synchronous processes that cannot happen separately. The reductant gives electrons to the oxidant during redox reactions. As a result, during the reaction, the oxidant or the oxidizing agent acquires electrons and becomes reduced, while the reductant or reducing agent loses electrons and becomes oxidized. A redox state is the combination of an oxidizing and reducing substance that is present in a certain. The definition of oxidation is a gain of oxygen and the loss of electrons or hydrogen. An atom or molecule undergoes an oxidation process when it loses one or more electrons. Iron, magnesium, sodium and other elements lose electrons more faster than other elements do. We refer to them as easily oxidized chemicals. When oxidation occurs, the following occurs. Oxygen or an electronegative element is added. Loss of an electropositive element like hydrogen. A rise in the positive charge and diminishment of the negative charge. Thus, oxidation is defined as a process of adding oxygen or any other electronegative element or removing of hydrogen or any other electropositive element in accordance with the classical or earlier concepts. Oxidation is a process via which an electron or ion loses one or more electrons according to electronic. Examples of oxidation reactions. For example, 2 magnesium oxide plus oxygen gives 2 magnesium oxide. Ferric chloride, hydrogen sulfide, mercury chloride can be explained under detailed examples. Now, what is exactly the procedure of oxidation? An atom's or compound's characteristic alter whether it is oxidized. Let us use the oxidation of iron as an example to better comprehend the oxidation reaction. Unoxidized iron is robust and long-lasting. Iron that has rusted or oxidized, however, becomes weaker. When oxygen-carrying water molecule comes into touch with iron things, they oxidize. Iron oxidation results in the formation of reddish brittle material on the iron object surface. This material is known as rust, and the rusting is the process of iron oxidation. These are the 3 electrons in pure unoxidized iron. Iron is a substance that readily oxidizes, losing all the 3 electrons in this process. Iron only has a positive charge after 3 oxidation. Reduction. The process of getting or losing oxygen is known as reduction reaction. When a molecule loses oxygen or gets one or more electrons, a reduction process takes place. The reduction reaction results in the following. Hydrogen or an electropositive element added, loss of electronegative elements or oxygen, reduction in the positive charge, a rise in the negative charge. Thus, reduction is a process that includes the addition of the hydrogen or an electropositive element and the removal of oxygen or an electronegative element according to the classical or older concepts. Reduction is the process by which an atom or ion gains one or more electrons according to the electron. Examples include ammonia plus hydrochloric acid, sodium plus water, and hydrogen sulfide plus sulfur. What is exactly the procedure of reduction? In most cases, oxidation and reduction reactions occur simultaneously in a reaction. The term redox reaction refers to the combination of oxidation and reduction. One atom or molecule undergoing oxidation loses electrons in the redox reactions, whereas the other atom undergoes reduction receives electrons. To put it another way, an atom or compound undergoes reduction by stealing electrons from another one. To put it simply, a redox reaction involves the movement of electrons or charge from one substance to another. Reduction usually occurs in tandem with oxidation. Chemical undergoes oxidation, it loses electrons to another component, which then acquires those electrons and undergoes reduction. An oxidizing agent is a substance that obtains electrons and a reducing agent in a compound that loses electrons. There are different types of redox reactions, like different types of matter and its transformations into other forms are involved in the chemistry. This happens as a result of several reactions. Redox reactions are among these many categories of reactions that are vital. Redox reactions come in a wide range of varieties. To have a better understanding of the classification of redox process, let us examine the two types of redox reactions, oxidation and reduction reactions, along with an example of each. Four main categories can be used to categorize these redox reactions: combinations, reactions of decomposition, reactions of displacement, reactions of disappropriate reaction. Combination reactions. This class of oxidation and reduction reactions, often known as redox reactions, involves the combination of two species of any atom or molecule to generate a single compound species. Redox reactions are only referred to this type of reactions whether both or either species. B, that is nothing but present in the elemental state, and A. The breakdown process is exactly the reverse of this kind of redox reactions, which involves oxidation and reduction. Coming to the second one, decomposition reactions. It is only a combination reaction in reverse. In these kind of reactions, a single chemical is broken down into two or more distinct compounds. Out of the two or more components, at least one product needs to be in its most basic form. Displacement reaction. An element is swapped for an atom or an ion in a compound. In these kinds of reactions, displacement reaction and not oxidation and reduction process is unique and is known as redox reaction. The same species will experience oxidation and reduction in the disproportionation. Only when one of the reacting elements has three different oxidation states can this kind of redox reaction takes place. Furthermore, while the lower and the higher oxidation states are present for oxidation and reduction respectively, the element in the interacting compound must be present in the intermediate oxidation state. The disproportionation of the oxygen species during the breakdown of hydrogen peroxide is a typical example of this reaction. Coming to the detailed version of biological oxidation, in order to generate significant amounts of Gibbs energy, which are needed to manufacture adenosine triphosphate or ATP, multiple steps or process of oxidation are employed in biological oxidation, reduction reactions, or simply biological oxidations. The glycolysis process needs to be close to a plentiful supply of oxygen in order to make ATP efficiently. Because glycolysis is inherently inefficient, pyruvate, the process final product, is converted to lactate using NADH as a reducing agent if there is an insufficient oxygen present. But in a more advantageous aerobic process, the citric acid cycle and the terminal respiratory chain are further steps in the breakdown of glucose through glycolysis, which in the final result, glycolysis produces carbon dioxide, water, which can be exhaled out with each breath. Large amounts of Gibbs energy, which are needed to create ATP, can be released by the reducing molecular oxygen, a process that is carried out by the products NADH and oxidative phosphorylation is the process by which electrons are moved from NADH or FADH2 via a number of electron transfer carriers. This process facilitates the formation of ATP by means of transport of electrons. The following are some particular instances of redox reactions which involve the transfer of electrons and hydrogen ions that are employed in biological activities. In certain biological oxidation process, electrons and hydrogen ions are transferred simultaneously. In other cases, the material being oxidized may lose hydrogen ions, may be involved in a third kind of biological oxidation. It should be highlighted that biological oxidation rarely happen directly and typically include a number of intricate